Uy, last problem. Actually, hanggang dito lang. Oo. So, i-pump. So, ito naman, paano kung pump? 'Di ba, ang tendency ng pump is to pump it up. Oh, ito na, nagja-joke na naman ako. No, actually, pump it up. Kaya nga may kantang pump it up. So, ang tendency niya kasi i-raise niya. Pataasin niya yung tubig, 'di ba? So, may mga pump naman yata kayong nakita na sa totoong buhay. So, kapag sobrang taas nung tangke sa taas, tapos manggagaling yung supply ng tubig mo, for example, sa baba, so ang gagawin mo niyan, i-convert niya into, ano ba, energy, no, para pataasin masyado, i-push pataas yung kanyang tubig. So, yun yung tendency ng pump. And considered siya sa hydraulics problems kasi nga, there is a change in pressure, a change in energy, of course. Okay? So, consider this as another sample para matutunan natin ang importance of hydraulics. So, if a pump draws water from reservoir A and lifts it to reservoir B. So, ito si A sa baba, nasa ilalim. Tapos, ipupush down ni pump yung tubig ba? O, water to point B. As shown in the figure. The loss of head from A to 1 is 3 times the velocity head in 150 millimeter pipe. And the loss of head. Okay, naintindihan nyo, wait lang. Isa-isay na natin yung term. So, the loss of head from point 1, para siyang equation actually. So, the loss of head from point 1 to point 3 is equal to the 3 times velocity head. Velocity head is v squared over 2g, no? V squared over 2g. In the 100, so at 150 mm. Actually, ganyan lang yan. Para lang, kumbaga sa algebra, yung ating long sentence, i-convert na lang natin sa formula, no? So, the loss of head, HLA, from 1 to 3, mali na naman ako. Okay? So, the loss of head from A to 1, sorry. Na-excite ako. So, the loss of head, HLA to 1 is equal to the 3 times velocity head. So, 3 by V squared over 2G at the 150 mm pipe. And then, the loss of head, ayan, may pangalawa. And then, the loss of head from 2 to B, so 2 to B, is 20 times. Wow. So, that is 20 times the velocity head of the 100 mm pipe. Ito na pala. Oh, ang galing ko. Oh, nakikita nyo na sa kanan. Okay? So, ayan, in formula form or mathematical equation, HLA to 1 is 3 times the velocity head. And then HL2 to B is 20 times the velocity head of the 100 mm pipe. Malinaw. Compute the horsepower output of the pump and the pressure heads at 1 and 2 when the discharge is 12 liter per second. Okay. Horsepower pala. Kabayo. Okay. So, hanapin natin si horsepower. That is a unit of energy or diba QYE? Mabasa. Si HP is what? And then, given man nga natin dito is dalawang diameter. So, D1, 150 mm. Itong 150, mas malaking pipe ay matatagpuan kay reservoir A. Ayan, nakaturo naman din, no? Malinaw. So, 150 mm si point 1 or yung malapit kay reservoir A. And then, pag angat niya dito kay reservoir B, letter B, ang kanyang diameter na lang is 100 mm. Ayan, nakaturo, 100 mm. So, divided by 1,000, 0.15 m lang. Tapos, dun sa dito, so 0.1 m. Then, given din yung kanyang discharge at 12 liter per second. So, kung 12 liter per second yan, divided by 1,000, so you will get 0.012 cubic meter per second. Okay, yan pa lang yung given. Ngayon, considering datum or datum line at point 8, so i-consider na lang natin na ito yung ating reference point. Itong part na to. Itong A. Ito pala. So, at point A, the elevation is 0. Nakita? Ayan o. Dito sa linya ni A, 0. Pero, kay ZP, so dito sa linyang ito, this is your 72 meters. Linaw. So, kaya siya naging ZA. ZA is our reference point. Water surface at reservoir A. So, that is equal to 0 meters. Tapos, pagdating natin kay B, so si B ay may height na 72. So, ZB is equal to 72 meters. Ngayon, hindi siya pantay dito sa point ni pump, right? So, si pump, syempre, nasa medyo ilalim pa ni part ng A. So, let's assume that this is your letter C. And then, your elevation at that point is negative 6 meters. So, from, di ba, Cartesian plane lang din naman yan. So, kumbaga, kung ito yung point ng 0 mo, so, any point beyond or below your 0, so, negative ang value niyan. Tapos, any point above your 0, so, that is positive value. Okay? Kaya, i-consider mo din yung negative side, no? Kapag mako-consider ka ng datum line or datum line. So, 72, 0, and 6. Nasa figure naman. Then, the velocity of fluid flow is inversely proportional to the area of its path. Okay? So, sa makatuwid, that is V squared over 2G. So, velocity is inversely proportional to the area. No? And then, since the reservoir has a large section, the velocity of flow is so slow. Sobrang bagal, making the water inside it to be almost stagnant. Therefore, it is safe to assume that the velocity of point 8 and point B is 0. Okay, so kagaya nung kanina sa problem number 4, since stagnant yung part na yan, tapos hindi din naman given siguro yung kanyang section, diba? So, ina-assume natin na VA is 0 and then VB at 0. That is the velocity at the water surface. Dun sa rurok, dun sa tuktok. So, VA is 0. And then, remember, free liquid surface is subjected to atmospheric pressure only. Ayan. Kapag sinabing atmospheric pressure, so the P at point A is also assumed to be 0. And then PB is also assumed to be 0 since it is exposed to atmosphere. Hindi siya kulob, no? So, we are talking about open surface. Ibang kaso kapag sarado yan, ha? Yung recall na lang po sa prelim. So, kapag open surface, we assume that the pressure at this point is equal to 0. Okay? So, ano pa ba? Next. Okay. So, sulat ko dito sa kanan yung given, no? So, the discharge, sabi dito sa first is 12 liter per second. So, 12 liter per second. 12 liter per second. Ulit-ulit. 12 liter per second. That is also equal to 0.012 cubic meter per second. Para hindi nyo natanungin kung saan ang gagaling. Sulat ko na lang ulit. Ayan, Q. Tapos, si diameter 1 is 150 mm, no? So, 150 mm. Si diameter 2 is 100 mm. Ano pa ba? O, yun lang naman. Tapos, given din yung sa problem, no? Itong sabi ko na 3 times the velocity head. Tapos, 20 times the velocity head. So, head loss meaning HL yun. HL from point 1 to point 2. Given yun, no? So, 3V1 squared over 2G. 3 times velocity head. ang tinutukoy na velocity head niyan is yung v squared over 2g automatically. Ito kasi ang term niyan is velocity head yan. Okay? So, kapag 3 times mo daw yun na yung HL, A to 1. Tapos, given din sa problem yung head loss from 2 to B, that is daw 20 times ng velocity head at point ng B or second point natin, so V2. So, that is 20 by V squared over 2G. Ngayon, ito ay mula lamang sa problem. Itong mga sinulat ko, no? Wala naman diyang hocus-pocus. So, kunin natin muna si value ng mga velocity. So, sabi ko sa inyo, continuity equation. So, kung ano yung discharge Q, that is also equal to Q1 and then also equal to Q2. Sa makatuwid, pwede natin gamitin na si 0.012 cubic meter per second is equivalent to your A1 V1. So, pi over 4 by the diameter is 0.15 or 150 mm. So, 0.15 is squared V1. Then, makukuha mo na yung velocity at point 1 is 0.6791 meter per second. Point 1. Then, pagdating mo kay point 2, so pwede mo rin gamitin na yung discharge na niya is 0.012 cubic meter per second is equal to the area at the second point. So, second point, dun sa may B, lumiit yung kanyang diameter, di ba? Naging 100 square meter. So, I mean 100 millimeter. So, pi over 4 by 0.1 is squared by V2. And you will get a velocity of 1.528 meter per second. Okay? And then, solving for losses na muna. So, given nga itong term na the head loss from point A to 1 is 3 times the velocity head. So, substitute mo lang yon, yung 3 times V squared. So, V1 is 0.6791 squared raised to 2 over 2 by the acceleration due to gravity of 9.81 meter per second. So, makukuha mo na ang HLA to 1 is 0.0705 meters. And then, dun sa head loss ng 2 to B, that is 20 times the velocity head. So, 20 times V2, which is 1.528. 20 na to, no? Sorry. Huwag nyo na pansinin yung text. So, 20 times 1.528 is squared divided by 2 by 9.81. And you will get another value of, calculate ko nga, verify ko ha. So, 20 by 1.528 is squared over 2 by 9.81. 2.38 meters ang kanyang head loss from 2 to B. Okay? So, wala pa tayo sa energy equation. Inisa-isa lang muna natin yung given. So, eto na. Mag-proceed na tayo kay Bernoulli's energy equation from point A to B. Kay Bernoulli na muna ako, ha? So, energy 1 minus head loss plus HA is equal to E2. Now, 'di ba, familiar tayo kay energy loss minus energy 1 minus head loss is E2. Ngayon, ma'am, bakit may HA? This is what we call the head added. Head added due to the pump. Due to pump. So, dahil nga meron tayong kinoconsider na pump na magpupush doon sa tubig pataas ng reservoir B, so there is a definite power or energy na nai-add, 'di ba? There is a definite energy added to the equation since the pump serves as an energy as a pusher to generate an elevation na mai-sustain niya yung from point A to point B. Therefore, we assume that that is the value of HA. And that is a positive value since again, 'di ba, pump it up. So pump is parang pang-motivate talaga, no? So pang-motivate tuloy. Pang-taas, pampaad ng energy yung pump na yun. Okay? So mind you that you have to consider HA when it comes to pump related problems, no? So hydraulics. Okay? Siya. The E1 minus HL plus HA is equal to your energy at point 2. Ngayon, itong head loss, considering all of the head loss na nangyari from point 1 or from point A to B. So, naalala pa? So, from point A to B, lahat ng head loss niyan considered. So, kung meron tayong dalawa kanina, yung 3 times the velocity head, tas 20 times the velocity head, na ito na nga nakuha natin, ito, solving for head losses, considered yan lahat. Kasama yan. Walang iwanan. Okay? Sama-sama tayo at walang mag-iiwanan. Okay. So, kasama yan, HLA, that is summation of all the head loss plus the HA due to the pump and then is equal to E2. Ngayon, as is pa rin naman yung energy or yung E1 saka E2. Kumbaga, V squared over 2G plus P over gamma plus CA pa rin naman yan. Diba? Ito si E1, ito si head loss, ito si HA, tapos ito si E2. So, anong nabago lang? Nadagdagan lang tayo ng HA, tapos yung head loss na kinonsider natin is from A to B. So, lahat yun kasama. Therefore, can I say that the energy 1 is equal to V squared over 2G? Since sabi na nga dun sa unang slide, the velocity is assumed to be 0 since napakaliit lang naman ng, kumbaga parang stagnant yung tubig dun. So, medyo no need to worry about the movement, the velocity at that point since reservoir nga siya. So when we are dealing with reservoir, the velocity at this at uppermost layer of the liquid is assumed to be 0. So VA is 0. Also, the pressure at an open reservoir is also assumed to be 0. No. And then ZA, since ZA yung inassume natin na datum or datum, tama ba? So ZA, yes. So ito yung point A, so ang elevation niyan is 0, no? So ZA is equal to 0, yung starting point. Now, to consider also head loss, so ang tatandaan nyo ha, negative sign yan. So, minus the summation. So, naka-parenthesis siya. Kasama siya dun sa bracket, dun sa parenthesis. So, 0.0705 plus 2.38. Meaning, i-add mo tong dalawa. No? So, 0.0705 plus 2.38. So, yan yun. That is equal to, i-add ko na lang, plus 0.0705 2.45. So minus na yan kapag na-add na natin. Gets? Paki-take note na lang nitong parenthesis. Okay, so 2.45 plus HA is still missing in our equation. So yun yung hanapin natin. Is equal to itong E2, so again, the velocity at point P doon sa water surface is assumed to be 0 kasi nga stagnant. Tapos yung pressure naman at point B is also assumed to be 0 since open surface. And then, ang meron na lang tayo is si ZB. Si ZB galing siya dito sa figure lang. Ayan elevation niya is 72 meters. 72. Okay? So, 72 meters. Then, ang nawawala na lang naman na dyan is HA. So, calculating that, i-dictate ko para masunod. So, 0 plus 0 plus 0 minus 2.45 plus x HA is equal to 0 plus 0 plus 72. Diba? Ang haba ng explanation ko, isisiro lang din yung pala yung iba. Sabi ka talaga, madam. Okay, so HA is equal to 74.45 meters. Yan yung HA. Now, to get the output, kasi ang hinahanap nga natin is HP, diba? HP is a unit of power. So, we got the power. Okay? So, to get that, you should multiply the flow multiplied by unit weight multiplied by the the head. The head added. Ayan. Okay, so since given man yung atin kanina na unit weight na 9810 kilonewton per cubic meter, tapos yung discharge natin is m³ per second multiplied by ito na ngang 74.4505, so that is meter. So ano makukuha nating unit? Diba, ang unit na lang natin is cancel out yung cubic meter, kilonewton meter per second. Kilonewton meter per second. And that is equal to 0.012 by 98. Ay, hindi pala siya kilonewton. Kasi pag sinabing 9810, newton na yun, no? So, newton per cubic meter. Again, newton meter per second. And ang isang newton meter per second, that is your watts. Yes, ang galing. Ang isang watt is equal to 1 newton meter per second. Kahit i-google nyo, sana tama. Pero tama yan. That is a unit of energy or power. So, 0.012 by 9810 by 74.4505. So, makukuha nyo dapat dyan is 8,764.31 watts. Ngayon, kung HP nga ang hinahanap, Diyos ko po, magko-convert pa pala tayo kasi 1 HP is equal to 746 watts. Conversion of units man na lang yan. And then, you will get that divided by 746. 11 na lang. So, 11.75 horsepower. Wow. 11.75 horsepower. Okay? So, yan yun. So, sana, pagkatapos nitong hydraulics, maalam na tayo mag-solve ng horsepower para pag mapili na kayo ng, mag-design kayo ng tangke, tapos, sa bahay, na may gagamitan ng isang pump. So, kunin nyo lang dun yung elevation, yung ano pa ba? Elevation. Makukuha ka dyan ng head. Tapos, multiply mo yung kanyang flow. Tapos, unit weight. May HP ka na. Pwede ka na mag-design. Galing talaga ng civil engineering. Anyway, so, the concept here is first, to understand the difference in elevation between point A and B, and then determining the points, no? So, at point A, at point B, tapos at point C, ganyan. And then also, determining anong value ng velocity ko, anong value ng pressure ko, para malaman ko yung pag-substitute sa energy equation. So, diba, hinaba-haba ng explanation, pwede naman palang zero yung velocity. Kasi nga, water surface. Tapos yung pressure exposed to atmosphere. So, that is zero. Ngayon, kailangan mo like consider dyan the difference in elevation. Z, yung datum. So, kung mag-start ka sa 0, tapos mag-end ka sa 72 meters, yun lang naman yun. Then, dito sa head loss, itong head loss naman, since given naman siya lagi sa, sa problem, may mga gantong terminologies lang na the loss of head from A to 1 is 3 times the velocity head. So, nakakalito siya kung babasahin mo, pero kung i-convert mo na siya into a mathematical equation or form, yun lang pala yun. Ano? So, 3 times v squared over 2g. Then, 20 times v squared over 2g. Ano pa ba? Ano pa? Ayan, HA usually kapag pump problem, HA ang hinahanap dyan. Iba din naman sa turbine. Turbine. Pero, saka na lang. Okay? So, ZP. Ayun lang. O, diba? Dali. So, I think that concludes the introduction pa lang naman kasi ito. No? So, that concludes the introduction to the fundamentals of fluid flow. So, kailangan nyo lang siguro tandaan yung continuity principle. No. That's all. Thank you.